A 750-gram aluminum pan is removed from the stove and plunged into a sink filled with 10 kilograms of water at 20 degrees Celsius. The water temperature quickly rises to 24 degrees Celsius. What was the initial temperature of the pan? All right, so let's make a list of everything we know. So we know the mass of, let's do aluminum first. Mass of aluminum is 750 grams, which is 0.75 kilograms. And we know that the final temperature, or let's do the C, the specific heat of aluminum. If you look it up in the book, it is 900. And you can also find this on the constants page under the resources tab up in the top right hand corner. It's 900 joules per kilogram times Kelvin. And we want to find what the initial temperature of the aluminum pan is, but they tell us indirectly that the final temperature is 24 degrees Celsius. The reason is we assume that the system reaches static, or not static, that the system reaches equilibrium, meaning that the final temperature of the aluminum and the water is the same of 24 degrees Celsius. So now let's do the initial of everything on the, or just everything on the water. So we know the mass of the water is 10 kilograms. The C for water is 4190. The initial temperature is 20 degrees Celsius, and that is 293 K. The final temperature is 24 degrees Celsius, which is 297 Kelvin. And then what is the initial temperature of the pan? So in this question, energy is conserved. So since energy is conserved, that means whatever energy we start with, we have to end up with. So we can write a Q for aluminum plus a Q for water has to equal 0, meaning we're not adding or taking away any energy from the system. So now that we have this, we can plug in the change of energy equation for Q. So Q equals MCAT. So we have MC delta T for aluminum plus MC delta T for water equals 0. Now let's move over the MC delta T for water. So MC, now I'm going to break up T delta T into T final minus T initial equals a negative MC delta T of water. We'll divide both sides by MC of aluminum. So now we have T final minus T initial of aluminum is equal to a negative MC delta T of water over MC of aluminum. Let's scroll down a little bit, and then I'm going to move it over here. So now we will add, or subtract, both sides with T final. So now we have a negative T initial is equal to a negative MC delta T of water divided by MC of aluminum. And then we subtract it over T final. Now we want a positive T initial here, so why don't we multiply both sides of the equation by a negative 1. So when we do that, we get a positive T initial is equal to, if we think of all of this as one term, we'll have a negative times a negative, so we'll have essentially a positive MC delta T of water over MC of aluminum. And now we're going to have a positive T final. Great, so now let's just plug it all in. Scoot up just a teeny bit so I can see all the stuff. Okay, so we have T initial is equal to mass of the water, so 10 kilograms times the specific heat, 4190 joules per kilogram times Kelvin. And then we're going to multiply that by the change in temperature, which was 4 Kelvin. And then all of that is over the mass of the aluminum, we said is 0.75 kilograms, times the specific heat of aluminum is 900 joules per kilogram K. And then we're going to add to all of that the final temperature, which we said is the same, so it's 297 Kelvin. So from that, we will get 545 Kelvin. Converting that to Celsius, we subtract 273, and that gives us 272 degrees Celsius was the initial temperature of the aluminum pan.